Welcome back, guys. Yes, Mr. Simpson will continue being your teacher. Yay! Yay! And if you have no idea what I'm talking because you weren't here on Monday, April 1st, well, you can ask somebody in your class. All right. And so today we are going to begin the very last subject of Algebra 1. Hooray! Hooray! You made it, son. You made it. All right. And that is exponential functions. And this is a new lesson. I have some guided notes for you. It will be posted in the Google Classroom along with this as well. All right, and so let's go ahead and begin. So, an exponential function, well, what is that? Well, simply, it's a function that has a variable as an exponent. And if you look right below, you can see the form that it takes. It's normal form. Y equals A times B to the X. And that A is the initial amount. Or you could think of it as the y-intercept. Okay, it's going to be the y-intercept for an exponential function. And then the B, of course, is the base. All right, guys, one of the things that we are doing here is just introducing exponential functions. You'll learn more about them in Algebra 2. And so there's really not a lot of math involved, but you do need to know that when b is greater than 1, it is an exponential growth. That means it's going to grow. And the line looks something like this. Okay? And the base equals 1 plus r, which is the rate. All right? And that rate has to be in a decimal form. Now, if the exponential, if the base is less than 1, it's going to look like this. Okay? Just to kind of give you an idea. And the base then is actually 1 minus r. Okay, and we'll talk a little bit more about that. It's an exponential decay. So let's take a look at something here. All right, so we need to write some equations, and this is mostly what the questions will be over on the STAR test, is make sure that you can actually write the equation. And so, look, my rate of my initial amount is 448. So that's my A. That's my A. My rate of growth. It's growth, so it's got to be above 1. And so this is 20%. 20% equals 0.2. And then I'm just going to add 1 to it to get 1.2. And so it's going to be 1.2 to the x power. All right. So that's it. My initial amount plus my rate. Now let's look at number 2. This time I have a rate of decay. Okay, and so I need to make that into a decimal, 6%. Hopefully you remember you move the decimal over left twice, make 0.06, and then 1 minus 0.06 is going to get us our rate, and that's 0.94. And so to put my equation, it's y equals a, which is 783. And parentheses, it's 0.94 to the x power. And that's it. Okay, number 3. And normally they're going to give you just a word problem that you're going to have to come up with. All right. So a radioactive isotope decays at a rate of 50% per minute. If the isotope begins with 200 milligrams, write an equation to represent the amount of the isotope left after m minutes. Well, so got y. Okay. What's my A? Well, hopefully you could say, oh, it began with 200, so that's my initial amount. All right. And it is decaying. So I need to put 0.5 or put 50% as 0.5 because that's the rate. And then I'm going to subtract it from 1 equals 0.5 and parentheses 0.5 to, let's say, to the m power. All right, so because that's minutes. All right, a population of rabbits is growing exponentially. Look at that word, growing. So here it's going to be above 1 at a rate of 8% per year. Well, 8% is going to equal 0.08, and so my base is going to be 1 plus 0.08. This is 1.08. All right, the initial population contains 22 rabbits. Y equals 22. And parentheses 1.8 to the x power. Got it? All right, and let's move on. All right, so for each equation here, we want to identify the initial amount, whether the exponential function is growth or decay, and the rate of growth or decay. So we're kind of working backwards from what we just did. So look up here. G of x equals 82.6 and then times in parentheses 1.7 to the x power. So my initial amount, that's what's outside the parentheses. It's A, that's 82.6. Is it growing or decaying? Well, if it's above 1, it's growth. If it's below 1, it's decay. So this is growth. And then 1.7 minus 1 equals 0.7, which means it's 70%. All right. Number 6, initial amount. Well, what's in front of the parentheses? 373. And this is decay because it's less than 1. Well, that must mean that my rate is 1 minus 0.4 equals 0.6. So it's 60%. All right, number 7. Again, kind of working. This time we're going to evaluate a function. So Jeff's, and that is a way to spell Jeff. Starting salary was $42,000 per year. Jeff received 5% raise every year after his first year. So the function is 42,000 times 1.05 to the x power. So hey, that's nice. They gave us the function. All right, what is Jeff's current salary after his first year? How much is making now? All right, so how much is making now after 7 years? Well, all I have to do is just evaluate m of 7 by plugging in 7 into this equation. And so, of course, I'm going to use my calculator. Going to plug that in, everything just like you see it. And you use the little caret, it looks like this, on the right side of your calculator under the clear button. And you just put in 7 here. And it will tell you that it is about $59,100. Okay, just rounding there. All right. The value of a new car decreases exponentially at a rate of 4% a year. If the purchase price of the new car is $38,000, how much is the car worth by the time it is paid. Now look, it decreases, so this is decay. All right, they didn't give us an equation this time. We're going to have to come up with our own. So y is going to equal 38,000 because that's my starting price. And then I got to find the rate. Well, it says decay, so I got to subtract 1 minus 0.04 because 4% is 0.04. That gives us 0.96. So 0.96 to the x power. Well, they want to know for year 6, so I'm going to do 0.96 to the 6th power. So 38,000 in my calculator times 0.96 to the 6th power, and that's going to tell me it's going to be worth 29,744 and 0.80 cents. And I can tell you that that has to be incorrect because that car is not going to be worth that much in 6 years. Anyways, let's go on and actually look at some graphs. Okay, here's a graph that shows the change of value of a car over several years. Well, and you can take a look. So this is it. The value is in thousands of dollars. All right. The time is in years. What is the value? The car increasing and decreasing. Well, hopefully you see that as X increases, Y decreases. So it's decreasing, right? Is the graph linear, quadratic, or exponential? Well, you can see it's not a line. It's not a parabola, it's an exponential. All right. From year 0 to year 3, how much did the value of the car change? Well, let's look. It started at 12, which is 12,000, and then at year 3 it's at 6,000, so it's 6,000. And how much does this compare to the initial value? Well, 6,000 over 12,000 equals 1/2, right? Okay. Let's go to 2. All right, the graph shows us an office worker's annual salary. So we take it and we look at it. He's starting at 5,000. All right, and as we move across X, X increases, Y is increasing, so he's increasing. And how much is the office worker's initial salary? Well, that's the y-intercept, and so it's just 5,000. All right. And so then they want us to write in an exponential equation using this value. Well, it's 5,000. Well, that's 50,000. Okay. And then I'm going to actually teach you how to do this tomorrow using our calculators. All right. So we're not going to complete that today. All right. The graph shows the number of coffee stores after 1992. Is it linear, quadratic, or exponential? Well, not a line. It's not a parabola. It's increasing, and it's increasing at faster rates. Okay, so linear, it increases. It increases at at different rates. Or sorry, linear, it always increases in the same rate. Quadratic, it's a parabola. Exponential increases at different rates. So that's, or it decreases at different rates. units. And so that's how it's a exponential. So how many stores were open in 92? Again, you look at your y-intercept, and it is 400. And so which of the following equation might fit the data? Okay, well, it's got to be 400 on the outside of the parentheses, so he's gone. All right, and then I got to think, hey, he's increasing, so my base has to be above 1. This means he's gone, and that's my answer. All right, guys, at this time, we're going to do a little activity in class. I had an assignment today, too, so if you are watching this because you missed today, well, make sure you come by and pick up that assignment. All right, guys, goodbye.